In this example video, I'm going to show you how to factor a trinomial with leading coefficient 1, and a trinomial with a leading coefficient that is not 1. So in our first example, as you can see, I have a trinomial because it has 3 terms with leading coefficient 1. So I'm going to show you off to the side a little something about trinomials and how they factor. So what I'm going to do is off to the side, I know that when I factor a trinomial, it's going to take on the form x plus a number times x plus another number, and I'm using P and Q to represent the places for numbers. So if I actually multiply this out, right, using the distributive property, what I'm going to get is x squared plus P plus QX plus P times Q. Now I'm skipping a few steps here, but if you work this out and combine like terms, you should get the same result right here. So what I notice is that this is my trinomial. P plus Q is the coefficient on x. So I'm looking for 2 numbers that add to this coefficient right here. Also, P and Q multiply to the constant term right here. So when I'm factoring a trinomial with leading coefficient 1, this is the method we use. What I'm going to do is take the constant term of -12, and I'm going to factor it. I need to find 2 numbers that multiply to -12. Then what I'm going to do is investigate those factors to find out which combination will add to the coefficient on my x term. So I'm going to go ahead and factor -12. I could have 1 and 12, 2 and 6, 3 and 4, and because this is negative, one of the numbers would have to be negative, right? So I've really got this group where these are negative and these are positive, or I could have this group over here, right? So there are 6 different ways to factor -12. So now what I'm going to do is come in and add these factors together to see if I get the coefficient on x, which in our example is 1. Okay, so coefficient on x is a +1 right there. So I'm looking for the correct 2 numbers that will add up to +1. So I've got 11, 4, 1 right here. That's what I want. 4 and -3 are my P and Q values. So when I'm factoring this, I'm going to get x minus 3 times x plus 4. And you can always check your work by multiplying this back out to make sure you get this quantity right here. If you are factoring a trinomial with a leading coefficient that is not 1, then what we're going to do is use what's commonly known as the AC method. Okay, so I'm going to give you the steps for this one. All right, so let's say our trinomial, okay, steps to factor ax squared plus bx plus c. A, b, and c are holding the places for my coefficients, okay? I'm giving you the generic steps. You can use it on any example like this one. So step 1, we want to multiply the leading coefficient a by the constant term c. In step 2, we're going to factor that product. Factor AC into 2 integers. But not just any 2 integers. I want 2 integers whose sum is b. All right, that coefficient on x. So far, this step is a lot like what we did in the previous example when the leading coefficient was 1. So you're going to use the same tactic here. Factor this so that the factors will add up to b. Then in the third step, what we're going to do is rewrite b as the sum found in step 2. And distribute. This will give you a polynomial with 4 terms. So what you'll do now is factor by grouping. Okay, so we're going to apply those steps here. So in our example, A is 6, B is -1, and C is -12. So the first thing I need to do is multiply A times C. So 6 times -12, which gives us -72. So what I need to do is factor my -72 into 2 integers that will add up to -1. Okay? So 72, if I ignore the negative right now and focus on 72, I could have 1 and 72. I could have 2 and 36. It looks like 3 goes in evenly. 3 times 24. How about 4? Yep, 4 goes in evenly. 18 times. 5 does not go in evenly, so how about 6? Yep, 6 and 12. In fact, that's how I got 72 in the first place. And then, oh, it looks like 8 can divide in 8 times 9. Okay, and I like to factor this way, 1, 2, 3, 4, 5, down this way, because I know when these two numbers are now next to each other, right, there's nothing else to do. Okay, so now what I have to do is decide what's going to be negative and what's going to be positive so that it could possibly add up to -1. So I want a difference of only -1, so I actually want this pair right here. And in order to get -1, the 9 has to be negative and 8 positive. So I found my two numbers right here that multiply to this but add to that. So what we're going to do is rewrite B as the sum that we just found. So up here in my original problem, my B value -1, I'm going to replace with -9 plus 8. So, and I'll write that down here on my paper. Okay. 6x squared plus -9 plus 8x minus 12. So I just replaced -1 with that guy. Then I need to distribute. So I'm going to take this x and distribute this here, which is going to give me 4 terms. And now I'm going to factor by grouping, okay? So remember, when you're factoring by grouping, you want to group terms together that have something in common. So I'm going to group the first two together and the last two together. And it looks like the greatest common factor of this group is 3x. I'll factor that out, leaving behind 2x minus 3. And in the second group, the greatest common factor looks like 4. And when I factor out a 4, I'm left with 2x minus 3. And looks like I need a new piece of paper. Now I see that the greatest common factor is right here, 2x minus 3. I'm going to factor that out. Leaving behind 3x plus 4. And that's my final answer. Okay, so to summarize this example, this is the goal, is to get here. But what we need to do are these 4 steps to get there. And you can see in the last step, you need to know how to factor by grouping. You need to know how to rewrite and distribute, okay? So this is commonly known as the AC method because the first thing you do is multiply A times C.